These notes are to show just a little bit different way to think about ratios, rates, and proportions than what we've done in class. So a ratio is a comparison of two quantities by division. So what that means is we're actually going to set them up as fractions. There are, however, three formats in which a ratio may be written. You can write it as a fraction, using a colon, or using the word to. For example, Miss Banks has 3 dogs, 2 cats, 2 birds, and 8 fish. We're going to write a ratio in all three forms to represent the scenarios. So dogs to cats, there are 3 dogs to 2 cats, and we can write that with the colon or with the word to, and then in a fraction form as well. We are going to leave these as improper when we're writing them as fractions. So fish to birds, 8 fish for 2 birds, 8 to 2, and 8/2. And then we do want to go ahead and reduce this or simplify it, but we are going to leave it as improper. Birds to total animals. Total is 3 plus 2 plus 2, so that's 7, plus 8 is 15. So here's my fraction form, my ratio form, or sorry, my colon form, and my form with the word to. So a ratio that compares two quantities with different kinds of units is called a rate. So before we were comparing animals and animals, that was just a comparison of two things. Here we're comparing different units, so words and minutes. When we simplify that rate, 102 can be both divided by 2. When we simplify that rate, it becomes what we call a unit rate. And what that means is that you're comparing something to every one of something else. For example, here we're comparing 50 words per minute. So these are some common unit rates that you're going to see. Number of miles for every 1 hour. We call that miles per hour. And you've seen those abbreviations before. And that's another name for your average speed. So if I asked you the average speed, you would tell me how many miles per hour we were going. So miles per gallon are some other common ones, also known as gas mileage. Dollars per pound, that's your price per pound. And that's our unit price. Dollars per hour is an hourly wage. So all those things just mean you're going to take this and divide it by that, because we've talked about that word per means divide. So for example, Elizabeth ran 24 miles in 3 hours. What was her average speed, which means miles per hour? So we're being asked to find the unit rate. How many miles did she travel in 1 hour? So in the future, you might not have this extra information there. You might just be asked, what's her average speed? And you'd be expected to know that that means we're looking for miles per hour. So in this case, we've got 24 miles for every 3 hours. We can reduce that on top and bottom. We can divide it, simplify. 24 by 3 is 8. 3 by 3 is 1. So now I've got miles per 1 hour. So 8 mph. Now we're asked to find the unit price. It's $2 for 6 oranges. So unit price is dollars per item. So in this case, we're looking at orange. So if it's $2 for 6 oranges, we can reduce this one. We can simplify by 2, top and bottom. That's going to give me $1 for 3 oranges. However, my unit price, I want to know how many dollars for every one item, every one orange. So what I'm going to do is use division. This means 1 divided by 3. So 3 goes into 1, Not at all. 3 goes into 10 3 times. 3 goes into 10 3 times. And then so on and so on and so on. So this would be a repeating number, which hopefully you knew from our last unit, 1 divided by 3, that's 0.3 repeating. So at this point, I know that it's 33 cents per orange. Oops, press the wrong button there. And I know that it's 33 and not 34 because, again, when I'm rounding to the nearest cent, money only has 2 decimal places. The 3 tells me that I need to stay the same, not go up. So on the next one, it says the prices of 3 different bags of dog food are given in a table. Which size bag has the lowest price per pound? So price divided by pound. So I'm going to do 49 divided by 40. Okay. And you should be able to do that math over on the side. I'm actually going to use a calculator so that you don't have to watch me spending all this time doing that. I get 1.225. And then I'm going to do 23.44 divided by 20, which gives me 1.172. 9.88 divided by 8, because again, it's price per pound, gives me 1.097 repeating. Because it's money, I'm rounding to 2 decimal places. So the 5 tells me that this is going to become 123. The 2 tells me that this is going to stay 117. And the 7 tells me that this needs to become $1.10. So which one has the lowest price per pound? That would be the 8-pound bag. Now we don't always use division. Sometimes we use proportions to help us solve for unit rates, as well as other types of problems. A proportion is an equation, typo, is an equation stating that 2 ratios or rates are equivalent. So to solve a proportion, we use a process called cross multiplication. So you should have seen this last year. We're going to multiply these 2 values, so 6 times x becomes 6x. And we're going to multiply these 2 values, so 18 times 4 becomes 72. Because this was originally equal, these amounts are equal as well. Now we've got a multiplication equation like we did a couple weeks ago. 6 times x, to get rid of that multiplication, I divide. That goes away and I have x left over. And 72 divided by 6 is 12. On this one, I multiply 15 times x, and that gives me 15x. Then I multiply 24 times 5, and that gives me 120. To undo multiplication, I use division. So x is equal to 8. So let's set up and solve a proportion. So Lexi painted 35 faces in 5 hours. How many faces can she paint per hour? Now we already know that when it says faces per hour, we want to put faces on top and hours on bottom. So we did 35 faces in 5 hours. However, I want to know how many faces she can do in 1 hour. Notice on the other side, I also put faces on top and hours on bottom. That's because it's faces per hour. So you can use the cross multiplication process to solve for this unit rate as well, in case you don't want to use the division that we did before. Because of course, if you cover up this side of the proportion, this is 35 divided by 5, which happens to be 7. Well, that's actually what we do when we solve this proportion. And that gives us, yes, 7 faces per hour. So you get the same answer, it's just a different process. It's useful that you learn this process because sometimes you won't be looking for a unit rate. In this particular problem, we said a rabbit can do 3 miles in 7 hours, but we're looking for its average speed, which is miles per hour. So miles goes on top, hours go on bottom. We did 3 miles in 7 hours. We want to know how many miles it can go per hour, so per 1 hour. So again, you can just divide if you'd like, or you can set up a proportion and use cross multiplication. You end up dividing by 7 and having to do this math anyways. It just depends on which way works best for you. So I plugged this in a calculator, and I'm actually just going to round to 2 decimal places even though it didn't tell me to. So this number tells me that this is going to be 0.43 miles per hour. So occasionally you're going to need to determine if 2 ratios are equivalent. We use our cross-multiplying technique, much like we do when we solve a proportion, to figure out if it's working. So on here, if I want to know if these are equivalent, I can always change these to decimal form and compare them. But sometimes it's a little bit quicker to use cross-multiplication. If these 2 numbers are not the same, then the ratios are not equivalent. 3 times 35 is 105. And 21 times 5 is 105. So these numbers are the same, therefore they are equivalent. Remember that equivalent just means equal. So the reason that this works is because if I was to set these up, these ratios, as a proportion, the only difference between this proportion and another proportion is that I already know what your x would be. So when I start cross multiplying, it says they're equal. And it's really a process of using your least common denominator to come up with that. So in this one, we get 1 on one side and 49 on the other. So these are not equivalent either. Our last example says a class of 24 students has 15 boys. What fraction, so we don't want the colon, we don't want the word to, we want a fraction to represent the ratio of girls to boys. So girls needs to be on top because this is girls to boys. You have to go in order. So we're looking for girls over boys. Well, we know there's 15 boys, but it doesn't tell us how many girls. It just tells us how many students. So 24 minus 15 is going to give us 9. So that means there are 9 girls. However, notice none of my answer choices matches that. That's because I need to simplify my ratio. Both of these are divisible by 3. So that means there are 3 girls for every 5 boys. And my answer is A. All right, so just a different way to think about how to solve unit rates and how to set up ratios and proportions. Please make sure that you're familiar with both this way and the way that we did in class.